This is our sun today, but it has not and will not always be this way. Grant Monty in the house. We're going to go on the tour of the life cycle of stars. This is a stellar nebula. It's awesome. It's also the first life cycle stage of a star. This is the Orion Nebula. Eventually, when a stellar nebula has gained enough mass, it will coalesce and go on to form the next part of the life cycle of a star, the average star. Or it will become a massive star, but we'll talk about massive stars later. This is an average star. It is the next cycle in the life of a star. The Red Dwarf Star is the most common average star in our galaxy. Our sun is an average star too. Our sun is about 5,800 Kelvin on the surface. Average stars are fueled by fusion of hydrogen into helium. Main sequence stars last about 5 billion years, depending on the mass of the star. This is the big red giant, and it's dying because it's pretty old. Red giants emit a redder color. They are around 100 to 1,000 times the size of the sun. Their temperature is about half as hot as the sun. This is the Planetary Nebula. It's kind of like a stellar gravestone. Even though it is not the last stage of a star's life. Planetary nebulas do not make planets. They were named Planetary Nebulas because of William Herschel, because they were round like planets. Outer layers of red giants are blown off over tens of thousands of years. There are 3 subclasses: asymptotic, giant, branch, protoplanetary nebula, and reflection nebula. This is a white dwarf. It is the coring down stage. It just runs out of heat. And it is about the size of Earth, but it has the mass of a star. The smaller the diameter of the star, the larger the mass. It has a stellar core, or hot cinder. White dwarf stars are formed only by stars with a mass of up to about 1.4 times the mass of the sun. If the stellar nebula does not become an average star, it will become a massive star. The temperature reaches 600 million degrees Celsius. Carbon fusion forms oxygen, nitrogen, magnesium, silicon, and neon. Once it reaches iron fusion, it only has minutes to live. Iron fusion consumes energy. This is the red supergiant. It has a helium core surrounded by a shell of cooling, expanding gas. It is the largest star by volume. It has greater than 10 solar mass. It has a radius of around 1.5 thousand times the size of our sun. This is a supernova. It's the next stage of a star's life. It is a gigantic explosion. It is briefly 1 billion times brighter than the sun. It must be 8 to 10 times the size of our sun. Elements heavier than iron are produced from the supernova. There are 2 types of supernova. The first type is a star that accumulates matter. There is a runaway reaction. The second type is a star that runs out of fuel and collapses. A black hole has no nuclear fusion to support the core. It swallows any matter and energy that comes near it. As it swallows the matter, it gives off X-rays. Sagittarius A is the name for a supermassive black hole in the galactic center. Neutron stars have around 1.5 to 3.2 times the mass of our sun. Some highly magnetized rotating neutron stars are known as pulsars. They produce pulsating radio waves. Another type of neutron star, known as a magnetar, is believed to have incredibly strong magnetic fields. Bye-bye. This has been Grant Monty. See ya out of the house.